Hello and welcome to the Reuse Company webinars. If you have any questions or comments about the topic, you can use the question section anytime during the presentation. We will have some time for Q&A at the end of the webinar. The webinar will be recorded, and in a few days we will send you the link to the recording. Next slide, please. The topic for today is MBSE zigzag pattern, a theoretical and practical approach. Today's presenter is Jose Fuentes, and my name is Cecilia Carlson. First, a few words about the Reuse Company. What do we do at the Reuse Company? Our company is a solution provider specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the system's engineering life cycle. Our presenter today is Jose Fuentes. He is the Chief Sales Manager at the Reuse Company. He has the INCOSE CSEP certification and has graduated from the INCOSE Institute for Technical Leadership. He is a member of the board of AIS, the Spanish chapter of INCOSE. Jose is an active contributor to the INCOSE Guide to Writing Requirements. So let's start. Hello, Jose.
Hello, Cecilia. Can you hear me well?
Yes.
Perfect. So welcome to this webinar. I will be speaking today about requirements and models and how to put all this together and how to make this live together and evolve together. So in the agenda of contents, I have prepared some interesting topics like first, since I will demonstrate how all this can become true with the help of a tool. I will highlight first what are the main pillars of the semantic interoperability implemented in this tool. Then, of course, as I mentioned, I will speak about requirements and models and how they need to be evolved together. Next point will be the so-called zigzag model or zigzag pattern, zigzag approach, where requirements and models requirements can go through from a requirements management tool into modeling tool so that things can be easier or more easily connected in the modeling tool. We will have a video demonstration, and the final block will be question and answer, where I recommend you, if you have, as soon as you have your thoughts or questions, please use the question box, question chat, to write down your questions, and at the end of the session, we will go through all your questions. So let's go right to the point. And as I said, I will start with the definition of the main pillars of what we call semantic interoperability. This slide, I think, represents this idea where, as you can see here, the first point is to include a series of different connectors. We, in our interoperability hub, we have connected nowadays something around more than 50 different tools, ranging from requirements management systems, model-based tools, PLMs, ALMs, and this also includes Microsoft Office, PDF, connection to relational databases, and so on and so forth. So the idea is to maintain connectivity with the sources, never to replace the sources. I mean, this is not a wipeout approach. And we will also maintain the authoritative source of truth on every of these different tools. And our approach also implies fully synchronized connectivity to these sources of truth. So whenever a new tool needs to be connected to this interoperability hub, I suppose that you could be using a tool which is not yet part of this interoperability hub, the first approach that we will be developing is a bidirectional connection, including a kind of mapping between the meta model of this new tool to be connected and the meta model of our interoperability hub, which is represented in the ontology of the synchronized source of truth. So by means of that, we will be always capable to transforming information, requirements, conceptual models, simulation, and other pieces of information. We will be capable of exchanging bidirectionally between this corresponding tool, the source of truth for a given piece of information, with our ontology, right? So we will always keep these two sources synchronized. So this is the key aspect of this approach. And with this approach in mind, we will be capable of connecting information from one tool to another, right? So I mean, the hub, the ontology, our ontology is just the path to connect two different elements from two different tools together, or transform elements from one tool to the other. One interesting point when it comes to this connectivity between different tools is that we will never promote point-to-point connectors. So there is no one-to-one connector between each one of these tools. On the contrary, whenever it comes to transform or connect information from tool A into tool B, there will be first a transformation between source tool and our ontology, and then from our ontology back to the target tool. So this is the two-step transformation that we will carry out, instead of having one-to-one or point-to-point connectors. So more graphically, these the 6 pillars of our approach starts with, of course, with this capability of connecting to this number of different tools, more than 50, as I said. Second is to enable the so-called semantic traceability or extended traceability, where in our approach, it is not only that we can connect the pieces of information that you create within a single tool, like suppose that you are deriving requirements in your requirements management system from one level to the other. Of course, if you only need to this kind of traces, then the best tool, of course, would be your requirements management tool. However, when it comes to connect your requirements to other models or other documents or whatever, as is represented in this screenshot, where everything starts with legislation in PDF format, stakeholder requirements in Excel, then system and subsystem requirements in DOS, risks, as far as I can see here, risks in Excel, conceptual model in Capella. So the idea is when it comes to deal with traceability in an heterogeneous ecosystem, this is where our approach makes stronger, right? Together with other semantic capabilities like traceability suggestions and these kind of things. There are plenty of webinars in our website speaking about all these additional traceability capabilities, like suggestion of traces, for instance, right? So the third pillar of interoperability is the possibility to move, somehow copy, move, but mainly synchronize information from one tool to another. So we have came out with a very complete tool that allows you any kind of potential mapping between two different tools. Let's say that you want to copy requirements from one requirements management tool to another, or as I will demonstrate today, copying requirements between requirements management tool and a modeling tool. So in this kind of mappings or synchronizations of information, first you start by defining which is the source and which is the target documents or models, which type of elements you want to copy, if there is any kind of transformation. In this case, as you can see here in the first columns, I'm copying requirements in the source and to be transformed into requirements in the target. However, it could be that you want to transform elements of type A into elements of type B with a given stereotype. You can filter which kind of elements you need to synchronize, which folder or package, or where more specifically you want to take the source or you want to leave the target. You can map properties and attributes, attributes from the source. Perhaps not all, but some can be or need to be synchronized with the attributes in the target, with the same name of the attributes, with different names. So all these are the possibilities that are offered in this idea of synchronizing information between two different tools. Then step 4 or pillar 4 is these kind of more let's say heavy transformations. Let's say so. It is not only that we can transform from conceptual modeling tool or modeling tool A to modeling tool B. It is also that we can transform the source into a different kind of target, right? As in this example, where we have started as a source with state chart with a number of different states, modes, and transitions, and guards, and whatever conditions, and we transform all these into textual requirements. It could be also the way back. It could be vice versa, transforming from textual requirements into models, model to requirements, generation of test cases. So we have implemented a series of different transformations in this fourth step. Then the fifth step or pillar is the binding, right? In the binding, what we do is we make a benefit of the traceability links. By the way, whenever we do synchronization or transformation, we also generate automatically traces as well as in the second step where traces are generated more, let's say, more manually. In any case, whenever two elements are traced, if the tool detects changes in one of the ends of these traces, of course, as any other traceability management tool, the tool will identify one or more of these links as suspicious links. You will have the possibility to see what is the impact of this change, how many other artifacts would be impacted because of the change in the source. And whenever you feel comfortable with this change, if you want to promote the change, let's say, downwards to other elements, and represent this, I will go back to this state chart here. Supposing now that I modify the name of one of my modes in this state chart, as I said, the tool will first let me know that there is a change in the model. Also, I will be capable of checking what is the impact of changes in the traceability chain. And also, finally, if I approve the change, then I could have, because of this binding approach, I could have the textual requirements automatically modified, replacing the name from the old name from the model, from the mode, sorry, into the new name that I have changed in a different tool, even if this change came from a different tool. And then the final step is remote connection or remote interoperability, where it could happen that, or the normal stage, or the normal usage of this interoperability approach is by just moving, copying, synchronizing information in your own ecosystem of tools from tool A to tool B. However, in many other cases, it could be that you need to share information outside of your IT infrastructure. Suppose now that I am the OEM here on the top right side of my slide, and I am developing a model. Suppose also that I use whatever modeling tool, let's say Cameo, for my model, but I need to share somehow pieces of this model with one supplier or a couple of different suppliers, right? So the idea is that I can take my modeling tool, I can create as many packages as I want, and when it comes that I open this model with our tool, with the Engineering Studio tool, I can provide or grant permissions to the different pieces of my package to different entities, so that I can say, okay, well, the first package, I want this package to be reachable by these two suppliers, but only in a read-only way, in a read-only mode. Okay, perfect. Then package 2 is read and write for the first supplier. Package 3 is read and write for the second supplier. And packages 4 and 5 are there is no access to these suppliers. So you just configure this and enable remote interoperability. When you enable remote interoperability, of course, there are permissions here and there, Active Directory, and many other ways to deal with this. But you can open the way for this supplier to reach the pieces of your model that you have granted permission to access, right? And the interesting point in here is that suppose that this supplier is not using Cameo. This supplier could be using, I don't know, Enterprise Architect or Capella, whatever. The point is that whenever I open the corresponding tool, the Engineering Studio as a client tool in this supplier, I could request access to this particular model in my customer, in the OEM side, and whenever I grasp the content from this model, there will be a transformation in the way, so that I will receive here locally. I will receive information in my own tool in Enterprise Architect, let's say. And of course, I will be capable of seeing what is inside package one, only read-only mode, and I will be capable of reaching package two in a read and write mode. I can provide my content in my tool, Enterprise Architect, and of course, I can do the same with this other partner. It could be directly having the partner connected to the OEM, or it could be directly opening new packages or sub packages from in Enterprise Architect to this other company. That of course could be using a third tool like Capella, right? Whenever I am done in any of these two levels, I will just save locally, and I can ask permissions to go back and inject back the changes. In this way back of the changes, of course, it is not only that I will be storing the changes locally and also remotely, but also there will be a transformation taking all these new pieces of information and modifications now back into Cameo, so that whenever I refresh my information here in the OEM, I will see all the changes, all the new content in Cameo, regardless the fact that this partner one was performing all these activities in Capella, and this other tier one company was working on Enterprise Architect. I will see everything now back in Cameo, right? So this is the way of dealing with remote connectivity, and this is kind of a summary of all these pillars, starting with the connectivity to the sources, the synchronization between our ontology and the sources, smart traceability, and something that is also very important in our approach is the notion of quality checking and verification and validation. Together with, of course, configuration management to be aware of every potential change that could occur at any of the levels in the chain of traces created with this approach, right? As I will mention in the next block, quality checking and the verification is key, right? Then it comes interoperability. So now that I have briefly described this model, by the way, we have other webinars in our website which that describe this interoperability approach in more level of detail, right? So now let me speak more right to the point into the topic, today's topic, which is how to put together requirements and models, right? And let me start with kind of definition. When it comes to working with models, we tend to think first that models, model-based systems engineering is the current trend in systems engineering. And we normally deal with different types of models at different levels of abstraction, perhaps starting with models to represent the need, right? While we will be also working with models to represent the solution or the solutions, if we want to involve also a trade-off analysis, the solutions to this need, right? So this is the way we normally deal with models in this MBSE approach. However, it is clear that we need to make room also for textual requirements, because requirements are the heart of the current system engineering practices. So according to INCOSE and the INCOSE handbook, a requirement statement is the result of a formal transformation of one or more needs or parent requirements into an agreed to obligation for an entity to perform some function or possess some quality, right? It is inherent to this INCOSE approach the need for textual requirements, right? And for many different reasons. text is normally a better approach when we start with our first interactions with different sorts of stakeholders like suppliers, customers, and many others. Second, legally binding documents are normally written in and signed, by the way, in textual format. High-level needs and other expectations like environmental expectations, regulations, etc., are normally expressed also as natural language. Some other expectations on a given document at a given engineering level do not require the formality of a model. And of course, certification is normally managed by means of textual documents. For all these reasons, we think that textual requirements and textual needs are not only useful, but are really fully necessary, right? And in here, you can see how INCOSE and the INCOSE handbook and the INCOSE guide to writing requirements is describing this flow of information from the highest levels of the integrated set of needs into design input requirements and design output specifications before you reach your final system of interest, right? It is important, as always in this guide, it is always important to highlight the need for verification at every different stage, like verifying that my textual requirements are meeting all the rules defined to write those requirements. A clear example of these rules could be the 42 rules in the current version of the INCOSE guide to writing requirement. Similarly, every organization is defining a series of different rules on how to create your design, what to do, what not to do, what is allowed at which level this is allowed or not, etc. All these need to be checked if we want to come out with a high quality system of interest in the end. And of course, we also need to make sure that the transformation from one level to the other has been done properly. Of course, all this by checking or verifying all these steps, we will manage, hopefully, to have an easier validation of the system and easier validation of each one of these other different blocks. Of course, verification and validation are different things, but if we don't start with the proper verification at the proper moment in time in the life cycle, then validation is pointless if verification has not been done properly, right? So the good point is that we also provide information not only to perform all these number of transformations and all these traceability, but we also provide tools for this requirements verification, for model verification, and to make sure that there is always a consistency between requirements and models. So if you visit our webinar section, you will reach a number of different webinars speaking about all these topics, right? So coming back to the notion of high quality requirements, we always like to enforce and to promote tools to help people write better requirements. It's like requirements assistant, helping engineer writing better requirements based on real-time checking of rules. Could be whatever rule you define in writing in the writing of the requirements. Perhaps, as I mentioned before, the 42 rules in the INCOSE guide for writing requirements. But of course, with the help of these tools, our RQA module, you can clearly define which are the rules that you want to obey for the different documents that you will be dealing with. Together with that, of course, there are plenty of rules or several rules in this INCOSE guide speaking about the structure itself of the requirement, and the guide itself describes or includes in Appendix C, I believe, describes a number of patterns to be followed. A pattern is a kind of the structure, the grammar for a well-formed requirement. I have included here the logo of EARS as an example of that. EARS, I hope you all know this. EARS is the acronym for Easy Approach to Requirement Syntax. It is a very simplistic but yet powerful a way of describing the structure of your requirements based only in six different patterns, right? So I like how powerful and how simple this is to implement, right? So the six patterns described by IAS is, or everything starts with the shorter, let's say, ubiquitous requirement where there is no condition, there is no context, and you just describe a system response for a given piece of the system. And provided that there is no context, there is no trigger, we will be thinking that this action or quality aspect needs to be activated all along the operational phase of your system, right? So this is the definition of ubiquitous requirement. Then we go to requirements that are ruled by a state. This requirement is active whenever the system is in a given state, or actions that are triggered by an external or internal event, like the event driven. Then optional features or unwanted behavior, describing the so-called rainy days activities. And then finally, the so-called complex pattern. I need to know that, as I mentioned before, I love this ES approach, but the only thing that I don't like at all is the name for this final pattern, because I don't like the name complex on it. I believe that this is, by the way, the normal complete pattern. So people tend to write requirements just expressing which is the entity and which is the action. Like an ubiquitous requirement, but most of your requirements at system level should not be ubiquitous, right? So to me, the more typical structure is this final one, and that's why I don't like to call complex to something which is the normal. To me, this is the normal, right? So in my example here, well, we can see this example with larger font here, right? It's something like while the temperature warrior, which is the name of my system, is in attack mode, and when the temperature sensor reaches the maximum limit established, the temperature warrior shall enter into idle mode. So what's important here is that, especially when it comes to deal with the requirements and models developed all together, hand on hand, what is important is first to have the help of a tool that helps me follow the structure of the pattern that I have selected, like this, well, complex, in quote, complex pattern. And also, important point is that as soon as I start typing the content for my requirement, starting with the while, if I have chosen this type of pattern, I need to start with a while statement, and then the name of a system element, and potentially I need to name a given state or mode. So what is important is to guarantee consistency between my piece of text and my model, and as much as possible have an assistant that could be showing in front of me which are the name of the entities that I can involve at this given level of abstraction. And as soon as I choose temperature warrior as the name of my system, I would like a tool to tell me, okay, temperature warrior could be in any of these different modes, A, B, C, D, E. So that I can, instead of just guessing what could be the name for this for this particular mode, I just take one that is offered in the requirements management tool, even if perhaps the name of this mode and the name of this component should be coming from the modeling tool, right? So similarly, when I write, for instance, the name of this other mode, it should be a mode that is not only that the mode appears in my model, it is not only that this mode is a valid mode for the subject of this requirement, which is also temperature warrior, but also these modes, attack mode and idle mode, they should be connected by means of a transition. So the only way for me to write these requirements and having these requirements fully consistent with the information from the model is if there is a transition already in the state chart connecting attack mode to idle mode, right? Of course, this only if you develop both requirements and models in parallel, right? but if you do so, of course, there is a need to guarantee consistency between both. In the second example, this second example is not following the pattern that is represented on the top. Now, this other example is just for an event driven, where everything starts with when keyword, when the temperature enters idle mode. This is not a state as a whole. I mean, the statement. This is just representing a given punctual trigger, just entering this mode. Then the temperature controller shall reset at the target temperature. Here you see the name of a function, reset the target temperature. If you need to be consistent, then of course this name has to be chosen among the name of different functions identified in your model. And of course, it is not only that the reset at the target temperature is a function in your model, it is also that this function is allocated to the subject of this requirement, which is the temperature controller, right? Of course, not to mention that temperature warrior should also have the idle mode as we described before. So whenever it comes to follow this kind of approach, we will be normally given the possibility to either work in two different tools. Okay, I develop my requirements in a requirements management system, and I develop my model in the modeling tool. This is the first block here on the top. Or I try to finish all my activities in the requirements management tool, and then I move all my requirements into the MBSE tool, so that all this traceability, consistency checking, and so on and so forth could be done more easily in one single tool. There are pros and cons for these two approaches. If we go to the top, to the approach where requirements remain in the requirements management system, then of course, to me, if we deal with the requirements management tool, this should be the source of truth for your requirements. This is the house of your requirements. Normally, these kind of tools offer better ways to manage requirements, filtering, searching, and plenty of other features for these requirements management tools that are normally not offered or the same level of quality when it comes that the requirements are managed in a modeling tool. Of course, something like cons now is that traceability requires a kind of gateway between your requirements management tool and your modeling tool, and both requirements management system and MBSE tools need to be used at the same time, right? So this could be the cons for the first approach. If we go down now to the second approach, of course, requirements and models are now in the same tool, which is very important, very interesting to have a quick access to your information. Of course, as I mentioned before, also traceability could become easy, at least from a technical standpoint. It is easy because all the information is in the same tool. So your tool, your modeling tool, should be allowing you to establish traces between the elements corresponding to the requirements with the elements corresponding to the architecture. And the cons are, as I mentioned before, normally MBSE tools offer poorer requirements management capabilities, and perhaps there could be difficulties in the reconciliation of changes in the requirements between the MBSE tool and the actual source of truth of your requirements, which is the requirements management, right? So pros and cons in both approaches. The important point is that whichever of these approaches you choose, we will be offering you possibilities to work with it. If you decide, like happens in this screenshot, same as I was showing you before, if you decide that okay, I need my requirements to be managed in a requirements management system, like those next generation in this, according to this icon, and I want my models in Capella, according to this. The idea is that with our tool, you have plenty of possibilities. First is our tool allows you to establish traces very easily between requirements and in a tool and models in a different tool. Second, even if your model is in a different tool from your requirements, all the consistency checking that I was describing before can be performed, and also the writing assistant in DOORS could be taking in real time information from your model, so that you can see in real time which are the name for your states, which are the name for your functions, which functions are allocated to a given component, and so on and so forth. All this in real time. So the first possibility in my previous slide is fully covered with this SES Engineering Studio, which is the name of this tool, and we have, as I said, plenty of webinars describing the quality checking, the quality authoring, traceability among all these tools. If you are interested in this approach, just visit our website and go to the webinar section, or just drop me an email. In case you want to move into the other approach, of course, there should be a transformation or synchronization for your requirements in tool A, in a requirements management system, into requirements in your modeling tool. And this is what some people call the zigzag approach. I have taken this picture for a very well-known source. You can. I invite you to visit this article. You have the link there, where everything starts with a requirements document here on the top, and individual requirements within this document. So I can create a requirements document for a transportation system, and I speak about, or I include requirements about distances, speed, and number of people to be moved from one side to the other. And of course, we can think that this is the problem space. When it comes to deal with the solution space, I have to come out with one or several potential solutions. One possible potential solution for this transportation system would be to deal with a car. And of course, this car will have a number of different main systems or main components, like the engine, the chassis, the entertainment system, and some other elements, right? So as soon as I have developed a little bit this first layer of my architecture, it comes to go back to the requirements area, requirements arena, and think now on each one of these documents separately, a document for the engine, a document for the chassis, a document for the entertainment system, and consider each one of those blocks, let's say, as a black box, right? So that if I start with the engine, I will be speaking about the power of this engine, the size, the consumption of the engine, and so on and so forth, from a problem perspective, let's say, considering the engine as a black box. Then whenever I have all these requirements, or in parallel, I can be developing somehow the logical architecture, the next level of the composition, only considering for the moment just the engine. And I can say, okay, I will be dealing with a special kind of engine, which is a hybrid engine made up of a battery, the engine itself, and the control system, and so on and so forth. So this is the idea. And we are moving from requirements field on the left to architecture field in the right, and then back to requirements, and then more architecture, more requirements, more architecture. That's why this model receives the name of this zigzag approach, or zigzag path, right? So if I now put it in a different way, we can now see this system of interest on the top, right? With a given document, considering this system of interest as a black box. And then on the right-hand side of this slide, I will be representing models, right? So that the first step would be to create the corresponding system of interest in the modeling tool. Of course, I can develop, if I need it, I can develop functions. I can, and of course, these functions cannot be just written or created in the modeling tool as just like that. I will need to somehow connect these functions to the corresponding requirements mentioning addressing this functionality, right? So that's why we can start with the SIG way. So we are moving, as I was representing, from the left to the right. So now I have requirements in the modeling tool. So this is the SIG. So that, of course, I can trace my functions into these requirements, right? Of course, I can connect functional flows. I can deal also with state charts. I can decompose somehow when needed. I can decompose my functions into sub-functions, and of course, I can decompose my system of interest into the corresponding subsystem, right? When doing all these requirements could be or should be need to be connected to the different architectural elements that I am creating. But at the same time, it could be that by making or taking these decisions, architectural decisions, of course, there could be derived requirements coming out after these decisions. These new requirements derived from the architectural decisions are those written in or shown in green. So these green lines are representing the new requirements, while perhaps there could be other requirements that perhaps were incomplete when I was in the domain of the problem. Perhaps those requirements were incomplete, and now because of these decisions, now I have enough information as to complete these requirements. It could be also, for instance, a TBD that now is solved now that I am in the modeling space and I have simulation tools, or I have more engineers connected to provide the missing information so that the TBD or TBC now can be done, right? So all these changes now are fully consistent with my models, but of course they still live in the modeling tool. While I mentioned here that I was embracing the second of my possibilities. If you remember the previous slide, 2-3 slides ago, I am in the second option, meaning that I need to involve both the requirements management tool and the modeling tool separately. And I want to deal with all these traces in the modeling tool. So since the source of truth of these requirements is on the left, I need, let's say, the saga way, where all these changes, the delta of these changes go back to the source, right? So that's why now we have here on the left also the new requirement and the modification. And of course, also all these traces are now created against the actual requirement. If the requirement, this is the actual requirement, while this here is the surrogate representing this actual requirement into the modeling tool. So the trace that initially I created in my modeling tool between this function in this case and this requirement now needs to be transformed into a trace between the function itself in the modeling tool and the corresponding requirement in the requirements management tool, right? And of course, we continue with the decomposition, second level decomposition, and so on and so forth, and we continue with the SIG and the SAG at different stages, right? So this is the idea. Now, let me go for a quick video where we can represent all this into two actual tools. In this case, we have chosen Polarion as the tool for the requirements, and Enterprise Architect, as you see here, like the tool for my models. This Enterprise Architect tool is only having some actors and some high-level use cases and nothing about the requirements. So that this is now the Engineering Studio. So this is the tool that allows for the traceability and interoperability and consistency checking. So all the activities that I was mentioning during the webinar can be executed or are normally executed in this Engineering Studio. So whenever I connect to a given tool, in this case my Polarion document, the tool will load the content. In this case, it is a very tiny document, only 150 elements in it, requirements in Polarion. And when I connect to the Enterprise Architect model, I will see how the tool, always using the API, the corresponding API from these two tools, now using the API for Enterprise Architect, the tool will collect the information. This color green means that this information is not yet persisted in the ontology. So I will save to make sure that the model is fully in sync with the information from the ontology. And then when the green color disappears and there is no green, no red, no yellow, it means that we are fully in sync. We can manage views. I think we can accelerate this a little bit. You can include you can open a given view. If you have already pre-recorded the view, you can just import the view from your hard disk, and so that you see that there is one new column here, like the owner. You can do the same in the other side. In this case, in the requirement side, you can modify the aspect of this view. I am accelerating this a little bit because it's just a basic definition of additional columns, link to given set of attributes, and just accommodating this in the screen and saving the content, right? So it's very easy approach, normal regular approach. I will be giving a value to this attribute. So now stakeholder is same stakeholder for all of my requirements. And of course, all these changes are making my requirement updated. And that's why all the requirements are having this yellow label here, meaning that there are changes that are still in memory. These changes, the two columns in yellow, means that the changes are not in the tool itself, are not in Polarion, and are not in the ontology until I save. When I save, the yellow of these two first columns disappear, meaning that what you see in the screen is fully in sync with what you have in Polarion and in sync with what you have in the ontology. So let's start with the interoperability, with the SIG approach, with the SIG goal of this approach. And we have configured a very easy SIG where requirements are captured in Polarion, but I need to select which package should be the destination, the target for my interoperability operation. So you can filter by type, you can filter with the name, whatever. And I would like all my requirements to be stored in this empty package. We have packages for the system analysis and for the logical architecture. So you just choose which one you want to choose as destination for this interoperability operation, right? So as soon as you choose your package, then you can continue with more detailed mapping, like for instance, which transformations you want to do. Requirements, the requirements management tool need to be transformed into requirements in the target. And I have chosen also that the value for the stakeholder attribute should be copied or synchronized with the owner attribute. So different names in source and the target, but it is not an issue. As soon as I execute my interoperability operation, of course, it can take time. In my case, it's a tiny document, so it takes 5 seconds or less to just to show all the content in the destination, right? If the document were larger, of course, it will take a little bit longer, but not that much, right? So now I see all these 150 different requirements, but they're still in green, meaning that they are not persisted neither in the ontology nor in Enterprise Architect. By clicking save, then the tool now is saving both. It's saving versus the ontology, and it is saving versus the modeling tool. So now the SIG is completed, and we can go to Enterprise Architect and check that the package that used to be empty, as soon as we refresh, now it is not empty anymore, and it contains my 150 requirements with the description and with the owner attribute that has been synchronized with the stakeholder attribute from Polarion. Then, of course, as I said, it could happen that new requirements appear, or it could happen that some requirements are modified. It could happen that traces are created, and these are all the aspects that we will be addressing in the video. First, we have cleaned out one of the packages, and we have synchronized back. So you see that every change in the original tool and the Enterprise Architect is automatically received into the target. And now, before we deal with operations in the target, and of course, before we deal with the SAG, I will be creating a baseline in Polarion, right? This baseline is created on top of our ontology that could be also synchronized with baselines in Polarion or not. So there's no need to fully synchronize baselines in our tool with baselines in Polarium. So the first change is just a change in the description of one of the requirements. The second change is a change in the only attribute we are working with today, which is the owner. So there are two changes for the moment done in the model side, right? And now I will create some elements. For instance, I can create. In this case, I will create a use case, right, with a given name, whatever. This use case, for the moment, will be created only in Enterprise Architect until you refresh the information in our tool, so that this information could be synchronized into the other tool in this operation, right? I can also create new requirements. To be also synchronized in a moment, to be synchronized with Polarium. For the moment, the requirement only exists at this given moment in time, only exists in Enterprise Architect. So I am, as I was describing in the slide, I am evolving my requirements with some requirements that are triggered because of the architectural decisions. And as soon as I refresh in Engineering Studio, I will see all the changes and the new elements, by the way. Here we are. So the new function, the new requirement, the requirements that have been modified. So everything appears here. This yellow and green aspect means that these changes has not been yet synchronized with the ontology, by the way. But the tool will prevent any operation until you are always in fully sync. So the only operations you can do are operations like changing your views and some others, but not you cannot start the SAG until all these changes are persisted into the ontology, right? So I have modified the view to see what is the actual text of my requirement. And now we are saving. By saving, we can save, of course, the changes in the view, but mainly we will be synchronizing the content from Enterprise Architect. Now is fully in sync with the content from the ontology. So that is the moment where we can start with the SAG operation. So the SAG is exactly the same as the SIG, but in the opposite direction. So same content, same filter, the opposite destination, of course, same mapping in terms of type of elements, same mapping in terms of the attributes, but now in the opposite direction. And well, I can just now execute the SAG operation. And by executing the SAG operation, I will have the delta of my requirements fully synchronized with, in this case, with Polarium. So I execute the SAG. Okay, this is now faster because there are only some few changes. And now I see my new requirement right on the top. And I can also check which are the rest of the changes. In order to do so, we can compare now the content, the current content of this element with the previous baseline that we have created. And then you see that there is one new element on the right, so this one in green, and you can see that there are two elements with modifications. If you click on the first one, then the tool will highlight that the modification is just on the description. If you click on the second one, then the tool will tell you that the modification comes in the attribute and not in the description, right? So thanks to the baselines, we can do these kind of things before you decide to save your changes in Polarium. So now by clicking save, all these changes will be represented both in our ontology, but mainly in Polarium, so that the requirements in Polarium now capture all the changes that I have done in the requirements field, but in Enterprise Architect, right? For the moment, this first SAG approach only took new elements and new content. You can do everything in one single operation. but here I have distinguished two different operations. The second one is where I will be creating traces between the different functions and my requirements, right? As I said, if you want to make this in only one single step, you are fully welcome, and you can do this in one single step. But now I have decided to take two steps. Now I'll be creating some traces between my different elements. So I create links in Enterprise Architect between some of my functions and my requirements. As soon as I refresh again in in Engineering Studio, then I will see new content in my model. These new content are not new elements themselves, but they are just new relationships, right? So I can save this in the ontology, and I can execute the same SAG operation. So no need to do changes, but the only thing you need to make sure that is provided is that in this SAG you need to deal with traces. So you need to choose which is the traceability module you want to deal with, okay, and which is the type of trace you want to create in, let's say, in our side, in the side of Engineering Studio, right? So as soon as I execute this second SAG operation, I can see which are the elements that are merged on top of the previous SAG that I executed, and I can see these traces in our traceability module. You can open and see it graphically, or you can see the traceability matrix. So plenty of ways to see all these connections in our tool. And I think we are done. So this is the end of the demonstration. We can move forward and we reach the question and answer section. I hope if you have found any question or doubt or thought, please let us know now. Check your question chat and write down your questions. Don't be shy. Cecilia?
Yes, thank you, Jose.
Do you really have any question?
Yes, we have a couple of questions already. Hi, Jose. How does SAS Engineering Studio handle conflicts during synchronization? For example, a system requirement edited in the MBSE tool that had further refinements in the requirements management tool after the initial baseline.
Yeah, whenever you perform any of these interpretability operations, the tool will, or let's say there are several mechanisms. It was very quick in the video, but there is one screen where I choose the merge operation. It is not a copy operation. It is not an append operation. It is a merge operation. So merge means that the tool will initially check if the possibility of changes in both sides. So in my example, when I executed the SIG step, there were only requirements on the left, let's say. When I executed the SAG, all the changes came from right to left, right? So my example, of course, yes, it was a very easy example. And normal life, as you mentioned, normal life normally implies that there are changes in both sides. Considering this scenario, when you perform the merge operation, the tool will let you know that if there are changes in element A1 in the left and element 2 in the right, no issue, both changes will merge. In case of changes for the very same element in the left and in the right, then there is a screen that I didn't show in this video, but there is another screen saying there are conflicts in element 1, 10, and 20. And then you can see what is in the left, what is in the right, who made the modification in the left, who made the modification in the right, what was the previous text in the left, what was the previous text in the right, so that you can choose which one you want to prevail, let's say, right? So it is a little bit more complicated compared with what I presented in the video, but with the help of the tool, you can manage to synchronize even if there are changes in both sides.
Okay, thank you. Another one, the demo had a flat list of requirements synced to the MBSE tool. Does SS Engineering Studio track movements of the synchronized element and recognize changes? For example, moving the requirement element to a package for grouping purposes.
Yeah, every operation that is executed either outside of the tool or let's say even operations that you can perform, modifications that you can perform from Engineering Studio, all these are fully tracked, right? Are fully tracked, meaning that I can always see all the changes as I try to represent with where I compared the current with the previous baseline. So the tool tracks every single change, so that you always decide if, in case of changes in both sides, in case of conflict, everything is fully tracked, so that you can always make your decisions.
Okay. From a practical implementation perspective, what is the scalability of the SS Engineering Studio? In other words, can one deal with potentially hundreds of requirements and thousands of model elements in large-scale systems?
Yes, this video, just to make it short in time, I only started with 150 requirements, and the model was almost empty, as I represented at the beginning of the video, right? But of course, this has been demonstrated in real scenarios with real customers. I can name some examples, but one of the largest is a company, one of our customers in the aerospace field, with real requirements and models, right? So it is not as tiny or as a toy like I represented in my video. So it was real big size document and model.
Okay. Well, this is connected to the former question. So based on that, a flat list, SIG, allocate functions in MBSE tool, SAG, restructure requirements as per functional decomposition?
Yeah, I don't know if I understood properly, but yes, in this operation you can also define, let's say, different sort of transformations with a different target, so that you can structure the destination in different ways. So in my example, yes, all the requirements from the left were transformed into a plain list of requirements in the right. However, is according to the different traces and allocation of your requirements, you can ask the tool to recombine and restructure the document if needed.
Okay, thank you. So that would be all. Let's finish here. Thank you, Jose, and thank you very much, everybody, for attending. If you have additional questions or want more information about our tools, don't hesitate to contact us by email directly to Jose or to contact@reusecompany.com. You can also find information and videos on our website, reusecompany.com, and on our YouTube channel @The Reuse Company. Thank you very much, and goodbye.
Thank you. Goodbye.